there. All right. So as we start off in pre-calculus, we kind of like to have like a level playing field that I know that you know these basic functions that you have learned through previous math classes. And so I kind of have like a tool, we call it a toolkit of functions that you should know inside and out. So of course it's day one, so let's see how well you remember it. If not, we'll get you there. Okay, so we look at functions 4 different ways. First of all, we are going to look at them algebraically. That's like with an equation. We will look at them numerically, which means looking at a table of values, graphically, which is obvious, and then a verbal description is really just for your own benefit to, like, when I say, hey, what does a square root function look like? You have like a word or phrase to express that. All right, that may vary for different people. Okay, so on your toolkit of functions, we're working on 1 through 8 today. And I'm going to do 3 of them with you. The other ones will be your homework. Now, I didn't want to just do the first 3 because those are the easier ones. I'm going to bounce around a little bit. I'm going to start with number 2, the constant function. It's actually super crazy easy, but sometimes those are kind of weird sometimes also. And this one sort of is. So the constant function, this is one where all the x values are paired with the exact same y coordinate. So that y coordinate will never change. It stays constant. And the notation that we would use for an equation on that looks like this. F of x is equal to k. It equals a number of some sort. Now, to do an example, I've got to like designate k. So in this case, I just chose 4. So the y value, f of x, is always going to be 4. So over here, algebraically, your equation would look like y equals 4, or f of x. We're going to try to use a little bit more function notation. So we'll say f of x equals 4. In a table, what that means is that you could plug anything you want in for x. Maybe you put in a -5. Y is going to be 4. Maybe you put in 0. Y is going to be 4. Maybe it's 3. Y is going to be 4. And I could go on and on. Now, what I want to do then is go ahead and plot some of those points. So if you plot -5, 4, it lands right here. And 0, 4 would land here. And 3, 4 would land right here. And you start to see the pattern. When we connect these points, it just creates this line. And that right there is your verbal description. Now, not just any line, and it's not a straight line because all lines are straight. The verbal description on this would be that it is a horizontal line. All right, now let's find out just some key information on these functions as well. So let's look at our x and y intercepts. The x-intercept is where it touches the x-axis, and you can see that the x-axis never gets touched. So there is no x-intercept, but the y-intercept hits right here at 4. So x-intercept, I'm actually going to write not applicable because it doesn't actually occur. The y-intercept is 4. Domain and range. Domain is your possible x values. I like to look at the graph and I just say, how far left does it go? And how far right does it go? Remember in interval notation that parentheses mean it doesn't actually equal that, and brackets means it actually does get to that value and it hits that. So infinity is not really a number. We always use parentheses. When you look at the range, that's your possible y values. And you can see from your table that your possible y values are all just 4. That's kind of weird, kind of hard to write in interval notation. A lot of times we will just write what that number is. So the range is going to be 4. All right, increasing and decreasing means as you read your function left to right, is the function headed upward or is it headed downward? In this case, it's neither. And I kind of left something out on this. So I'm going to say that it's never increasing, it's never decreasing. And the third option is that it stays constant. And that's what's going on this one. It is perpetually constant. So I'm going to say it's constant from -infinity to infinity. All right, that's kind of what we're doing. We've got 8 of them. That's 1. All right, let's go ahead and move on. I'm going to jump to number 4 on your toolkit. This is the square root function. I guess I'm choosing this because I'm not sure that you maybe are as familiar with this one. So let's go over one that we're not as familiar with. The square root function as an equation. Now, what we're doing today are the parent functions. This means they are the most basic. There's no shifting or stretching or anything going on with it. It's the most basic type of that function, and those are called parent functions. So in this case, it's f of x equals the square root of x, and I'm going to make a table of values. Since I'm square rooting, I'm going to be kind of picky about what I choose. I'm going to choose numbers that will square root nicely, and 0 is always a good start. So square root of 0 is 0. Then I would go to 1 because it square roots nicely. Square root of 1 is 1. And then I'm going to jump. I'm going to put in a 4. I don't want to put in a 2 or 3. They don't square root nicely. But the square root of 4 is equal to 2. And I might go one more, 9, 3. All right, let's go plot these so we can look at this graphically. Here's 0, 0, 1, 1. This teeny tiny graph, sorry. 4, 2, and 9, 3. And so it goes and swoops up like this. Okay, normally I would like to put in some negative values in my table, but I can't in this situation because the square root of a negative would be imaginary, so it would not actually be a real solution. So I'm not going to put any negatives in this case. The graph actually just starts at 0. It doesn't have anything to the left of that. The verbal description that I like to use on this, and whether you realize it or not, we haven't done the quadratic. You'll do the quadratic function where it's the parabola. This really is a parabola. It's the same shape as a parabola as far as these numbers in the table. It's just that they happen to be swapped. So this is what I like to refer to as a sideways parabola, but it is important to recognize it is only the top half of the parabola. Up here it says, since the symbol, the square root of x, represents only the principal or the positive square root. We're trained a lot of times to, when we see that square root, we're supposed to have that plus or minus on it. That plus or minus only goes there when you initiate the square root symbol. When you like square root both sides of an equation, that's when you put the plus or minus on it. If the square root is already there as part of the function, then you don't put the plus or minus on it. It indicates that it's just the principal or the positive version. So think about, I'm going to go ahead and throw it in here since I'm got this far into it. If we did have the plus or minus, it would mean all of these values right here wouldn't just be 1, it'd be 1 and negative 1, 2 and negative 2, 3 and negative 3. But if you did that and graphed it, that means you'd have a point here also, and a point here, and a point here, and it truly would be a sideways parabola. The problem is if we had that, it would not pass a vertical line test. So it wouldn't even be a function, so it wouldn't make the cut for being on our toolkit of functions. All right, lots of reasons. Okay, in the end, here's my verbal description. I'm going to call it the top half of a sideways parabola. All right, your x-intercept and your y-intercept both happen to be 0 in this case. Sometimes people will write your intercepts as an ordered pair. You can do that if that's how you were trained to do it in Algebra 2 and College Algebra, go for it. I tend to just put the number itself. All right, your domain is how far left. The farthest left it goes is 0. And it actually does hit at 0, so we're going to put a bracket to show that. And then how far right? Well, that arrow shows that it is going to keep on going. Your range, how low does it go? The lowest it ever gets is also 0. And the highest, it will gradually get higher and higher and higher. All right, so as far as increasing and decreasing, as you read this function left to right, you're looking at whether it's headed up or headed down, and it is headed upward as you read it left to right. When you do increasing and decreasing, you're always listing the x values as it goes from left to right. So it starts at 0 and it continually increases all the way to infinity. So I'm going to write 0 to infinity here. Now, actually, when we do increasing and decreasing, we don't get caught up on whether they're parentheses or brackets. That's only on domain and range. So we always use parentheses on the increasing and decreasing. And then it never decreases. You could just like ignore that, or if you want to say not applicable, I guess don't ignore it because that makes it look like you didn't know and you just left it blank. Do something. I think on that previous one, I just put a slash through it. Let's put not applicable. Doesn't happen on this graph. All right, we got one more. All right, I'm jumping to number 7. This is the reciprocal function or the rational function. The parent function is really just a reciprocal function, but it really, as we start doing more with this function, it'll really be more what we think of as a rational function. Either way, the parent graph is just a 1 over x, and the graph of it is going to look like a hyperbola, but it's not going to be the hyperbola like when you did ellipses and hyperbolas and parabolas and circles, the conic sections. It's not like that kind of hyperbola. We'll look at it when we get it graphed. All right, now, I didn't give us much room here. This table is kind of lengthy. So I'm going to actually start over here because I'm probably going to have a continuation on my table. So I'm going to start off and I'm going to put in, I like to put in, start kind of think left to right. So I'm going to put in a negative 10. And the reciprocal function just means, hey, do the reciprocal. The reciprocal of negative 10 would be negative 1/10. I could put in a negative 2, and I would get a negative 1/2. What if I put in a negative 1? What's the reciprocal of 1? Still 1. What if I put in 0? That's problematic because I can't divide by 0. That's undefined. So I'm just going to write undefined, and we'll have to decide later what that means. I'm not done, though. I actually need to put in some fractions here. I'm going to actually put in like a negative 1/2. And the reciprocal of a negative 1/2 is a negative 2. And I'm going one more, negative 1/10, and the reciprocal is negative 10. All right, so I'm going to plot these points. I haven't even put in a positive value yet. So let's look and see what happens. Negative 10 down a 10th. That's kind of hard to show, so I just like put a dot there. Negative 2, negative 1/2, also a little tricky, but should be a little bit further away from my axis. Negative 1, negative 1. And then 0. Okay, I kind of went out of order there because 0 is sort of my first instinct, but then I should have done this negative 1/2 and negative 1/10 first because negative 1/2 gets me a negative 2, so that's like right here. And then the negative 1/10 gets me a negative 10. I'm way down here. And you can see what would happen is if I kept going, it's going to keep getting closer and closer and closer. And so the graph of this thing comes around here. It will never hit those axes. So what that means is that those axes are asymptotes. Our graph gets really, really close and starts approaching them, but it doesn't ever reach it. That's called an asymptote, and that's an important part of your graph. Include those asymptotes as part of your graph. All right, we're half done. Okay, the next thing I would do is put in positive values. But here's the thing. The positive values, if I put in a positive, I'll get a positive back, which would get me values up in this quadrant instead of down in this quadrant. And the shape of my graph up here is going to be exactly like this graph. So I'm really not going to take the time to do the table. I'm just going to replicate this graph up in this quadrant. So the key point that you're hitting there is at 1, 1. And then it just approaches your asymptotes. This. And that is our reciprocal function. You can call it a hyperbola. I don't know. But remember the hyperbola from when you did conic sections looked like this. You had the box, then you drew in the diagonals, and it came in and just hit right there. Well, it's approaching those asymptotes, and that's why this is like a hyperbola, because it approaches asymptotes on both sides. All right. Your x and y intercept, well, heck, we've got asymptotes on the x-axis and y-axis. So we will never have any intercepts at those places. We have asymptotes at those places. Your domain. Okay, this gets a little bit sneaky or tricky. All right, so the farthest left this thing goes is negative infinity. And it keeps going and going and going and going. And then it starts, like it's going a little bit closer and closer, closer to zero, but it will never hit zero. So what I'm going to do is I'm going to say negative infinity to zero. It doesn't hit zero, so I'm going to do a parenthesis. But the graph isn't done. It jumps over to the other quadrant. And so what we say is it's in union with, do you remember that notation? In union with, and you pick it up again. And it picks up at zero and heads to infinity. And ultimately what this is showing is it really could be anything except zero there. But this is the interval notation that we use. When you look at your range and you look at how low it goes, well, it goes to negative infinity. And it does the same deal. It comes up, 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 and then it gets close to zero, but it never hits it. So we're back to that same thing. In union with, and then it picks up at zero and heads to infinity again. All right, as far as increasing and decreasing, let's look at this as you go from left to right. This thing is pulling away from the asymptote and it is headed downward. So this is a decreasing function. When you go to this branch, it's also a decreasing function headed downward. All right, so it is continually decreasing. So there is never an increasing part. I feel like we got to show, though, that there's some sort of a break happening there. So my decreasing, I'm really going to write, it's really going to look just like these others did. It's going to decrease from negative infinity to zero, but then it had a break in it. And again, this is not domain and range. We don't really use the in union with. It's really a comma. And then there's another section of the graph that's decreasing, and it goes from zero to infinity. All right, and then I have one other thing to throw at you, and it's this function 1 over x squared. That's not really the reciprocal function anymore, but it is a rational function because you have your x in your denominator. In college algebra, you would have looked at what happens when you have a 1 over x versus a 1 over x squared, and I'm just real quickie like going to put it in here. Ultimately, when you square your x value, it's going to force that to go positive on you. And so you're not going to have that branch where you were down here because those y values will always end up being positive. So this branch pops up to here. Now the shape of it's a little bit different because of the squared as well, but we don't get too caught up into that. And so ultimately, here's what my 1 over x squared would look like. They're just both going upward. I think sometimes some teachers say it looks like a volcano kind of look to it. All right, there's 3 of them. You've got 5 left to do. So your homework tonight is to finish this worksheet through number 8 and then do the syllabus quiz that is in Google Classroom. All right. Oh, and make sure you're working on getting that calculator also. We will need a graphing calculator soon. You can run to the library and get it. All right. Glad to have you with me. Good luck.